Hello everyone and welcome back to the OpenGL 3D game tutorial series. In this 8th episode, we will see how to create a basic entity system. In particular, we will see how to design an object-oriented entity system, how to integrate the entity system in our current architecture, and finally, we will see how to create and destroy entities in our game world. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create a basic entity system. So let's start with the requirements. We need a C++ IDE. In this series, we use Visual Studio on Windows and Qt Creator on macOS and Linux. The target platforms are Windows, macOS, and Linux. The target graphics API is OpenGL, and last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. What's the problem to solve today? We want to create a basic entity system in order to create a game world full of objects of any kind. Before to start though, let's see what is an entity system in few words. The entity system provides the necessary functions to create the structure of the game world, composing it with a list or even a tree structure of objects called entities. An entity can be defined as an empty or abstract object with no particular feature. So how can we transform those abstract objects in something concrete like the cubes and the various objects we are seeing on the screen? There are various approaches to define concretely an entity. Today we will see a simple approach based on the object-oriented paradigm, for which it is possible to give shape to a specific entity by deriving it from a base class with particular features. For example, if we want to create the player that can be shown on the screen as a 3D object, we can take a base class like mesh entity and extend it with our own custom entity class like MyPlayer. In this way, we are able to exploit the graphics functionalities of mesh entity class and provide even custom logic like player movements and so on through our own MyPlayer class. Very well, let's start to design our entity system. As first thing, let's create the main class OEntitySystem. This class should be allocated by the OGame class, and since the OEntitySystem instance should be deleted together with OGame instance, let's use the composition link, the one with the black rhombus. Then the OEntitySystem is in turn composed by a list of potentially 0 or more entities. Here we are referring to a list to understand the concept. Concretely, we will not use a simple list during the implementation. At this point, we can start to create our own game by creating a package called game. We can interpret this package as a folder, in this case, the game folder we have already created previously. In this package, let's create the MyGame class and let's derive it from OGame class. Now we can override the onCreate and onUpdate virtual methods in our MyGame class in such a way to implement our own logic. For example, in the onCreate method we can add the entities to our game, and in onUpdate method we can handle general logic of the game. Now, as we have already done with the OGame class, we can add the onCreate and onUpdate virtual methods to the OEntity class. OnCreate method is called when the entity is created. OnUpdate method, instead, is called at each iteration of the game loop, and so at each frame. providing the delta time value to allow the implementation of movements, animation, and so on. The next thing to do is to extend the OEntity class to an example class that we can call MyPlayer. Here we can override the just mentioned methods of OEntity class in order to add our own custom logic. That's all. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's add the entity folder inside include folder. Here, let's create the OEntity system class. Let's create the entity folder in the source folder as well. Now we can start to add the constructor and destructor to the OEntity system class. Good, at this point let's go to the OGame class. Here we have to clean the things a little bit. Let's add a forward declaration to OEntity system class. We have to try to keep the amount of include directives inside header files as minimum as possible in order to prevent cross-references. At this point, let's add a unique pointer of type OEntity system. Here we should remove the OGraphics engine header file and move it where it is really necessary, that is the C++ file. Let's add the OR prerequisites header file in order to provide the basic types and definitions. Let's make the callback methods on create, on update, and so on protected methods, in such a way to prevent the final user to call them without permission. Now we can also make the destructor of OGame class virtual. In this way we can destroy derived classes of OGame class from pointer of base class type without issues. As last thing, let's add a forward declaration even for the OGraphics engine class. Very well, let's go ahead and let's finally allocate a unique instance of the OEntity system class. So far so good, now it's the time to create the OEntity class. As usual, let's add a constructor and a virtual destructor. Now that we have the OEntity class, we can go to the OEntity system class and we can start to manage all the entities of our game world. We can do this by adding a map with a key value of type size t. This key will correspond to the unique identifier of the type of the entity class we want to store. We will see how to retrieve it in few moments. We store unique identifiers of the various entity class types here in order to allow query operation over the various entities quickly. Now, for each type of entity class, we have a further map that manages the unique pointers to the various entities created. In particular, we assign a row pointer to the OEntity instance as key, and a unique pointer to the same OEntity instance as value. The row pointer as key is pretty useful here because it will allow us to find quickly the entity we want to release or destroy from the game world. All of this will be more clear in few moments. Good, now it's the time to implement a really important method, that is the createEntity method. In order to allow the user to create any kind of entity, we have to make createEntity a templated function. To define a templated function, we have to add template keyword above the function signature. Then let's add the less than and greater than characters. Between these two characters, we can add a list of template parameters. In this case, we need only one template parameter that defines the type of the entity we want to add to our game world. So let's add the template parameter by adding the keyword type name and the name of the parameter. In this case, let's use a simple t. T can be seen as a placeholder of any class type, like OEntity type itself or our own custom entity classes, and so on. That means T will be replaced at compile time with a concrete class type. This class type will be defined by us later when we will use the createEntity function. At this point, let's return a row pointer to an entity of type T from the createEntity method. Then we have to find a way to allocate the instance and store it inside our map. Before to start, we need to know that all the code based on template parameters must be placed in the header files. All of this because if this type of templated code was implemented inside C++ file, the compiler wouldn't be able to resolve and recognize the T parameter at compile time, and so it will throw compile errors. Perfect! Let's start to implement the function, and let's check if the type T we are going to use is effectively a derived class of the OEntity class. We can do this by using static assert and isBaseOf functions. In this way, we can prevent the user to use non-entity types. Good, let's move on and let's retrieve the unique identifier of our entity type T by using the typeID function. So far so good, now it's the turn to allocate effectively our generic class in this way. Since we don't want to dirty the header file further with implementation code, and since the next part is not based on the usage of template parameters, we can add a further method called createEntity internal and place all the non-templated code there. Let's add as parameters a row pointer to a generic or onEntity instance, and the unique identifier of the entity class type. What we have to do now? Well, as first thing, let's assign the ownership of our generic or entity instance to a unique pointer. In this way, we handle the deallocation of the entities automatically. The next thing to do is to finally place our entity inside the map. As first thing, we have to retrieve the map of all the entities of type ID. To do that, we can simply add two brackets and place the ID between them. At this point, we can use this map and call the inPlace function to insert our entity pointer. Unfortunately, it's not that immediate. We have to place the row pointer as key, but we have to use a particular function to place the unique pointer we have just created. This function is called stdmove. stdmove allows to move the entire content of the object passed as parameter, in this case the unique pointer, to another object of the same type, in this case the unique pointer inside the map. But why we use stdmove here? In order to transfer the ownership from a unique pointer to another one without lose the scope. Let's remember that if the scope of a unique pointer ends, it deallocates the instance it manages. Very well. As last thing, let's add to the entity class a callback method called onCreate, and let's call it after we have handled everything in the createEntity internal function. At this point, we can turn back to createEntity templated function, and if the createEntity internal method returns true, let's return the row pointer to the entity. Otherwise, let's simply return a null pointer. Perfect, we can finally create our own custom MyGame class. Here we should use various classes of OGL 3D system. So, to simplify the things a little bit, let's add another file inside the include folder, and let's call it all. Here we will place all the header files of the OGL 3D system, in order to be used easily by the high-level classes, like our game for example. At this point we have to inherit from our game class, and let's add the onCreate callback method. Let's try to create an entity inside the onCreate method. The problem is that currently we are not able to reach the createEntity function just created. To solve this problem, let's add a getEntitySystem method inside our game class. Let's add the various header files of our entity classes. And here we can finally understand how to pass the entity class type to our templated function. As last thing, let's go to the main C++ file, and here let's replace the OGame class with our own custom MyGame class. Don't forget to add the method of the superclass in the onCreate method, in particular now that contains all the code related to the creation of the cube. We can start to compile and debug it. Let's place a breakpoint beside the createEntity function line. We can step into the various functions by pressing F11. As you can see here, typeIDE generates a numeric unique identifier for the type of class we want to create the instance from. Then we instantiate concretely the entity, and finally we step into the createEntity internal function. Here we move the instance to a unique pointer. We place it inside the map, and as we can see here, the previous unique pointer has become empty because it has moved inside the map. Then let's call the onCreate callback method. In this case, it does nothing. And in the end, it returns the row pointer. Very well! At this point, since we are able to create entities, we have to be also able to release them. So let's go to the OEntity class and let's add the release method. Unfortunately, again, it's not so straightforward. We have to refer in some way to the OEntity system class from the entity in order to access the map in which the entity is placed. To do that, let's go to the OEntity system class and let's add the removeEntity method. Let's add a row pointer to the OEntity to delete as parameter. Here we have to add a set of row pointers to all the entities we want to destroy. Let's call it entities to destroy. But why we want to store those entities in a further container and we don't remove them immediately? The reason will be more clear in few moments. For now, let's add the row pointer to the set. At this point we have to loop over this set to effectively remove the entities. But in what point? Let's add a further method called update. This method is like the onUpdate of the OGame class, and it should be called at each iteration of the game loop. In this method, we iterate over the set of the entities to destroy and for each entity to destroy we have to retrieve the map of the entities of the same type. This can be done by using the ID of the class type, but we didn't store it yet. So let's go to the OEntity class and let's add a size_t attribute ID. In order to be used inside the OEntity system class, let's make the OEntity system a friend class of OEntity. Now, in the createEntity internal function, let's assign the ID of the class type. Let's retrieve it in the update method, and now that we have retrieved the map of entities, we can finally call erase. Once the erase function is called, the unique pointer deallocates automatically the instance for us. So far so good. Once we have finished with the set of entities to destroy, we can clear it. What next? Well, we have to call the removeEntity method from the OEntity class. To do that, let's add a reference to the OEntity system inside OEntity class. Very well, the last thing to do is to go to OGame class, and in the onUpdate method we have to call the update method of the OEntitySystem class. At this point we should improve the onUpdate method of the OGame class a little bit. Let's add a delta time parameter and let's leave it with an empty implementation. Then let's add a private onUpdate internal method, and in the C++ file let's replace the old onUpdate with the onUpdate internal. Let's replace it in the low-level files as well, in this case in the cwin32 game C++ file. In the end, let's call the onUpdate method of the OGame class before the call to the update method of the OEntitySystem class. Very well, we have nearly finished. The OGL3D system is nearly ready. Let's make some tests in our custom MyGame class. So let's start by adding the onUpdate method. Then let's implement a simple logic. After 3 seconds from the initialization of the game, let's remove the entity. Let's compile and debug it. The entity seems to be created correctly. Let's see now if it is released after 3 seconds. So let's place a breakpoint where the release function is called. 1, 2, 3. Good, it seems to work. Let's see if the entity is released correctly. Yes, the entity is removed from the map and correctly deallocated through the unique pointer. Perfect! The very last thing that remains to do is to try to make our own custom entities. To do so, let's add the onUpdate callback method even in the OEntity class. Then, in the OEntitySystem class, let's go to update method, and here let's loop over all the entities stored in the map. For each entity type stored, let's retrieve its map of entities. Then, for each entity inside that map, let's call the onUpdate method and let's pass the delta time value. At this point, OGL 3D is finally ready. Let's make some tests. Let's add a custom entity class called MyPlayer in game folder. Let's copy and paste the content of my game, and then let's derive MyPlayer from the OEntity class. Let's try to create MyPlayer entity from my game class, and let's move the logic used previously in my game inside MyPlayer. There is only one problem though. We don't have any getEntitySystem function in the OEntity class. Let's add it. At this point there are some compile errors. We have forgotten to include the OpenRequisites header file in the OEntity class. Good, let's debug our code. Well, the onCreate method of our entity class is called. Let's see if even the release method is called after 3 seconds. Very well, it works. That's all for now, folks. Today we have seen how to design and implement the foundation of an entity system. The next time we will see how to design and implement the graphics entities for our entity system. I hope you enjoyed this video. See you soon. Thanks for watching.